Hello, good day. Today we're going to talk about linear functions. Linear function is defined by f of x equals to mx plus b, where m and b are real numbers. M stands for slope and b stands for y-intercept. Its graph is aligned with slope m and y-intercept b. And these are the conditions that a function can be considered as linear function. First is, if m does not equals to 0, then the degree of the function is 1. If m is equals to 0 and our b does not equals to 0, then the degree of the function is 0. If m or our slope is equals to 0 and b, our y-intercept, is equals to 0, then the degree of the function is not defined. Okay, we have here a linear function. Okay, this one is what we call the function name. And then that one, our x, this one is our input. And this one is what to output, meaning in this expression we're going to find our output. Okay, if we're going to read this function, it is f of x equals to 5x plus 2. That is how to read for a linear function. Again, f of x is equals to 5x plus 2. Okay, that is how to read the linear function. Okay, example number 1. Okay, f of x is equals to 2x plus 3. Okay, is the function a linear function? Can you consider this one as linear function? The answer is yes. Why? It's because it has a highest exponent of 1. And it is also written in the form of f of x equals to mx plus b. Okay, if it is a function, what is the slope or our m in the given function? So you must look at this one. Okay, our slope m is 2. Okay, from that linear function, what is our y-intercept? Our b. So you will look at this portion here. That is, our y-intercept is 3. Okay, so if from that given, that is our slope, then that one is our y-intercept. So, I mean to say that when you encounter a linear expression or linear function, you have to always consider that the numerical coefficient is the slope and the last term is our y-intercept. Okay. Second example, g of x equals to minus x. So as you can see, the name of our function is g. So any variable, any letter can be used as the name of your function. Okay. So is that a function? Is the function a linear function? Okay. It is yes. Because the given function has a degree of 1 and can be written as g of x equals to negative 1x plus 0, meaning to say that the slope of the given function is 1 and the y-intercept is 0. Okay, so take note, take note. If you encounter a given linear function look like this, it is still a function. Okay, example number 3. H of x is equals to x squared plus 5x plus 4. Is the function a linear function? The answer is no. Why? Because the given function has a degree of 2. This one. Okay. So let's try this one. Determine whether h is a linear function or not. Check yes if it is a linear function and no if it is not. Write the degree of the function. For linear function, identify the slope and the y-intercept. So as you can see in our heading, these are the given function, the degree. This one depends on your answer. If it is yes or no, then this M stands for the slope. No, once you encounter the letter M in function, that means that is our slope, and this B refers to y-intercept, because as we go along with the linear function, we will encounter, or we will use the letter M or the variable M and B, which is referring to slopes and y-intercept respectively. Okay, for number 1, the given is f of x equals to 3x plus 1. It is a function or not? No. Not yet, no? The first question is what degree? No, what degree? Before we decide if it is a function or not. Okay? So, the given is 3x plus 1. So, as you can see, that x has an exponent of 1. So, meaning to say, the degree is only 1. If it has a degree of 1, meaning it is a function. If it is a function, what is the slope? So, when I said slope, you are referring to this figure. So, that is 3. What is the y-intercept? So, you have to look at this one. That is 1. The next function. The function is f of x equals to negative 2x minus 8. Okay. So, what is the degree? So, as I said, this is, for x is 1. So, we need to say this is, the degree is 1. If the degree is 1, then that is a function. Okay. What is now our slope? So, you look at this one. That is negative 2. What is our y-intercept? This one. That is negative 8. Okay. For number 3, f of x is equals to 7x. What is the degree? 1. Okay, because the exponent of the given variable is has an exponent of 1. And then, it is a function or not? Yes, it is a function. Now, if it is a function, what is your slope? Your m. The slope is, that is 7. You must look at this number. Okay. Now, what is our slope? As you can see, it is not written look like this. But you can rewrite that one by like this. F of x equals to 7x plus 0. Okay. You can rewrite that one like this. So, I mean to say that our y-intercept is 0. Okay. Next. F of x equals to negative 4 times quantity x squared minus 5. X squared. This is x squared. Okay. What is the degree? the degree is 2. So meaning to say, this is not a function. This is not a function. How about this one? F of x is equals to quantity x minus 3. So if we're going to simplify this one, that is equals to 6x minus 3. Okay. So if that, in that case, the degree of our function is still 1. Then it is a function. Then what is our slope? Our slope is 6. This is referring to this one. No, this is 18. Sorry, this is 18. Okay, when you multiply 6 times 3, that is negative 18. Negative 18. Okay, so mean to say our slope now is negative 18. Now, next, the second to the last, f of x is equals to 10x squared plus 7x. What's the degree? The degree is the highest, no? So when you find the degree of a certain expression, you have to look at the highest exponent of a variable. So for this, the degree is 2. So if the degree is 2, that is not a function. Linear function. Remember that a linear function is having a highest exponent of 1. And it is written in the form of f of x equals to mx plus b. Okay. Then the last number is f of x equals to 3x squared minus 5x plus 1. Still, this is not a function, linear function. Okay? Okay, I hope you understand how to identify whether a function, given function is a linear function or not. Okay, next. How to evaluate function given the value of x. For example, here, we have a function, this one, f of x equals to 2x minus 1. So how to do it? To evaluate, no? If x equals to 3, negative 3, then our f of x, our function, would be like this. So instead of writing x, you will write the value of x, which is negative 3. Then substitute 2 times negative 3 minus 1. So if quantity 3 is equals to 2 times negative 3, that is negative 6 minus 1. Then at x equals to 3, the value now of our function is negative 7. Negative 7. So that is at x equals to negative 3. Okay. How about this one? When x equals to 0, what is the value of our function now? So that is 2 by substitution, the value of x is 0 times 0 minus 1. Okay, this is 0 minus 1. So the value of our function now at x equals to 0 is negative 1. Negative 1. Then, when x equals to 2, then our function would be our function f up to will be equals to 2 times 2, which is the value of our x, then minus 1. So this is equals to 4 minus 1. So the value of our function at x equals to 3 is equals to 2. Equals to 2 equals to 2, then that is equal. The function of when x equals to 2, that is 3. This is the answer. So after that, so this is how to evaluate the function using the given expression. If we're going to plot this one in a table of values, it will be look like this. So as you can see that when x equals to negative 3, our f of x is equals to negative 7. If our x is equals to 0, our function is equals to negative 1. Then, if x is equals to 2, then our function is equals to 3. Okay. So, this table of values is presented in horizontal way. But we can still use in this way, vertical presentation. So, in that case, our axis is our domain and this f of x values is our range. Okay, remember that f of x is just the same as your y. Take note of that. Once you encounter f of x, it's just the same story with y. Okay, so if we're going to plot that one in a graph, let's say the first one, when the value of x is negative 3, in this portion, when the value of x is negative 3, the value of our f of x or our y is negative 7. Negative 7. This one. If the value of x is 0, so this point, then the value of y is negative 1. So here it is. Okay. When the value of y is 2, value of x is 2, the value of y or our f of x is 3. So there. Okay. So how are we going to write the ordered pair? For this one, this point is our coordinate of 3 and 7. Meaning to say, this point is the value of x there is negative 3 and your y is negative 7. And here, the value of our x is 0 and the value of our y is negative 1. For here, the value of x is 2 and the value of y is 3. So when we connect that one, that is now our graph of the function of the given function. F of x equals to 2x minus 1. Okay. Is it minus 1? Let us see. To be sure. Okay, minus 1. Minus 1. So, this is the graph of a function f of x minus 2x minus 1. For more video about this one, you can visit my channel Ronski Kabski for more videos for you to learn. For this time, thank you for viewing my channel. Good luck, God bless, and good day. Keep safe.